Hello everyone, I'm Ravish and today we are going to discuss one data visualization technique which is very popular in machine learning interviews and data science interviews. It is widely used in stock market as well and popularly known as box plot. So let's discuss this visualization technique in greater detail. So before moving forward, let's first discuss what is the importance of data visualization in data science and machine learning. So data visualization is a technique using which you want to summarize the data in front of business stakeholders. Like suppose you are presenting some kind of data format in front of many different professionals or your team members or higher business professionals or maybe some kind of clients as well. You won't be showing any kind of like suppose we have a tabular data set, numerical data set that we have in the form of features and number of samples. This data in the numerical format will not give them much a wider picture. But when you will try to summarize the whole information, whatever you want to convey by using some kind of visualization technique, it will be very much easier for them to understand and get a grasp of data what you want to try to what you are trying to convey to them. Some of the popular data visualization techniques that you can see is like representing using the pie chart. The same information, if I would have given you, that would not have stuck into your mind. But if I am giving it into a format of by using some kind of pictures, human mind reads the picture very efficiently, but only when those pictures are already known to you. If you are using some kind of very novel idea to represent your data set, and if that idea is not so popular, so what will happen? You will try to convey and you will try to uh, explain that information first to the viewers, and then they will understand what exactly you are trying to convey. So, but in when we talk about popular data visualization techniques like the pie chart, histogram that is currently, or maybe the bar graph, these are very popular data visualization techniques, and people know how to read it. So they will easily get a grasp of complete data, and uh, this is the importance of data visualization in machine learning and deep learning. So it helps you to convey the entire information of data using some kind of pictorial format. So let's, in this particular video, we are going to discuss the box plot in greater detail, which is also very popular and widely used in machine learning industries and data science industries. So let's quickly see the box plot. So what exactly is the box plot? So if suppose we have the tabular data means we have some features, feature one, feature two, like suppose feature one, feature two, and feature n. There are n features we have. And we have suppose n samples, sample one, sample two, sample three, sample four, till sample n. So if you will try to convey the same information, for like suppose we are talking about this feature first, feature one. How exactly you will try to convey the whole information that is present in this particular feature? So one particular approach is use the 5 point summary. You want to summarize the data, whatever information is present in this particular feature, you want to summarize it, but with the help of 5 points. 5 points means we will discuss what are the 5 points using which we want to summarize the data, the entire feature that we have. Those 5 points are what is the maximum amount, or what is the maximum number that is present in that particular feature. Sorry, what is minimum, what is maximum, what is the first quartile, median, and third quartile. Please be with me. I will quickly convey how exactly you can calculate the first quartile, third quartile, and median by using the quartile technique. We will discuss this. This is one of the most asked interview questions as well, like how to calculate. They will be giving you some kind of data and will ask you to plot or find the median, plot the box plot out of it. So today we are going to discuss how exactly we will be calculating all the 5 points using which we can easily plot the box plot. So you have understood, like, this is the box plot. The leftmost point, actually, that this complete dot is actually representing the minimum. This dot represents the maximum, and this box is corresponding to, this line corresponds to median, which is already represented here. This line corresponds to third quartile, and this line corresponds to first quartile. And we make a box from starting from first quartile to third quartile, and then one vertical line is there at the median point. So this is the complete box plot, which is a 5 point summary of the entire feature. So let's discuss first how exactly we will calculate the first quartile, median, and third quartile. But before that, let's understand what is quartile. Okay. So quartile is nothing but, like, suppose if we have 100 samples in a data set. One feature has 100 samples. Okay. 100 samples. If you will try to arrange the data, like suppose if we have the data something like this, 55, 57, 96, something like that. Okay. When you will try to arrange, we have 100 samples in this particular list, or maybe array. So in this particular list, we have 100 samples, and when we will try to arrange this data in the ascending format. Ascending format means the data in the increasing order, strictly in the increasing order. Any data, any sample, if suppose lying at this position, then the samples which are right to it will always be greater than or equal to, like suppose this is sample 1 and this is sample 2, then sample 2 will always be greater than or equal to S1. And when we will talk about sample 0, so sample 0 will always be less than equal to sample 1. So this is the arrangement. You know the ascending order in the increasing order. Like suppose if we have 0, 5, and 9 in the increasing order, it is arranged in the increasing order. So this is ascending order. So when you will try to like arrange the data in the ascending order, the first 25% of the data after the arrangement, first 25% of the data you put into the bucket 1. Like suppose this is the this is one particular subset of the data. First 25%. The second 25% will go to bucket 2. The third, third 25% will go to bucket 3, and then fourth 25% will go to the bucket 4. All these buckets are called quartiles. This is first, this is second, this is third, and this is fourth. Okay. So the first quartile represents the first 25% of the data which is already arranged in the ascending order. Okay. So the first 25% will go into the first quartile, second 25%. So what I trying to, if suppose we have 5 numbers, 5 entries, then you can't say that like first 25%, or maybe like in one of the cases, you want to divide, suppose like these 5 samples into the four buckets. Then in one of the bucket, there will be more than one sample, right? So we definitely can't say that in all quartiles, all the numbers of samples will be equal, but definitely the first 25%, what exactly we are trying to convey is like, we will try our best to put first 25% into the bucket 1, next 25% into bucket 2, next 25% in bucket 3, and next 25% in bucket 4. By combining all these 25%, we will reach 100% of the data. Okay, these are called quartiles. So you understood the quartile concept. Now let's think about how exactly this quartile will help in calculating the median, first quartile, and third quartile. So the boundary between first quartile, second quartile, this is first quartile, this is second quartile, Q1, Q2, Q3, and Q4. So the boundary between Q2 and Q3 will be called as median. It means the boundary between second quartile and the third quartile will be called as median. It will be equal to our statistical median as well. Okay. Now, when we will try to find the boundary between Q1 and Q2, Q1 and Q2 is nothing but the boundary between first quartile and the second quartile. That boundary will be called first quartile. Okay. That boundary will be called first quartile, and the same will be going with the boundary between Q3 and Q4. The third quartile and the fourth quartile will be called third quartile, Q3. Okay. Now, these are the 3 numbers along with maximum and minimum represented by the box plot. The box plots represents the 5-point summary of any kind of feature. These are the 5 points. First quartile, where exactly the first quartile is standing, where exactly the third quartile is standing, where exactly is the median of that particular data, that particular feature, what is the maximum value present in that feature, what is the minimum value that is present in the feature. But we have learned that these are the 5 points, but how exactly we can calculate the median, first quartile, and the third quartile? So let's first discuss that as well. Like suppose if a list is having odd number of elements, like suppose 0, 1, 9, 7, 6, 5, 4, 2, 3, 8. These are the 10 samples in our data. Okay. Now suppose we want to find the median. What exactly we will do? We will have to first arrange the data in the ascending format. Please remember, this is very important. We always forget this to execute this step to execute. So if we try to arrange it, it will become 1, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. These will be the 10 samples after the arrangement. Okay. Now, in any data, this will be the first step. Once that is done, we will have to find what is the middle element. Okay. Middle means there should be same number of samples left to that particular sample, and there should be the same equal number of samples that is right to the sample. Okay. Currently, it may be a kind of, there are 2 kind of possibilities. Okay. The length of the list can be either even or either odd. In case of odd, when the length is odd, finding the middle is very easy. Like suppose take a smaller example, when we have 5 elements in the data, which is already arranged in the 5. So our data is already arranged in an ascending order. So what is the middle element? So we can easily say that the third element which is present here, it will be the middle element, because when compared to this element, when we will take the reference of this element, the number of elements that is left to this middle element is 2, and the number of elements that is right to it is also 2. So that's why it is the middle element, and we can definitely say that this is our median. We are talking about the arranged, ascending order arranged data. Okay. Now, when we have the even number of data samples, in that case, like suppose we have 6 samples, 0, 1, 2, sorry, 1, 2, 3, 4, 5, 6. Okay. So when we have 6 samples, we can't find the middle. So if you will say this is the middle, then in the left side there are 2 samples, in the right side there are 3 samples. If you will say this is the middle, then in the right side there are 2 samples, in the left side there are 3 samples. So in that case, we will have to consider both of these as a kind of our middle. Okay. And if both the things are our middle, then we will have to count the average of these two elements, and that average will be considered as our median of the data. This will be equal to our equal to the statistical median of the same data that we are talking of, these 6 elements. But when we will, like suppose this element plus this element, here also if you will see, so we have 10 elements. What will be the median? So if you will see, fifth and sixth elements. Okay. No, fifth. What will be the fifth? Fifth is 5 is definitely 1. 0, 1. So so if we will try to calculate which are the two numbers that are present in the middle. Think. There are 10 samples. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. So we will have these two numbers as our middle. Definitely. Think these two numbers as our middle. So in that case, what will be the average of this? Average of this will be 4 plus 5. 4 plus 5 divided by 2, which is nothing but 4.5. 9 by 2. 9 by 2 is nothing but 4.5. So the median of this data will be 4.5. Any confusion? So we already have seen what will be the average of what will be the median when the case of even number of samples is present in our data feature, and when there will be odd number of samples present in our data feature. So in both the cases, we learned how to calculate the median. Now, with this median, how we can calculate the first and third quartiles? Let's quickly see. Okay. So like suppose in case of even number of samples, like we have 0, 1, 1, 2, 3, 4, 5, 6. So in that case, both of these numbers were treated as a kind of middle. And in that case, we found that this is the average of these two numbers, and we found the median. Okay. So now once we have found this number, so there the data is split into the two parts. One is left to the median, one is right to the median. Okay. Now to calculate the first and third quartile, what exactly we need to do? The first quartile will lie at the median of the left data. This is very easy. So like if we have already found that in case of even number of samples, we found the average here, and left to this average, there are 3 samples. And if the list has three odd number of samples, then what is the median? The middle sample, which is this data. So this will be treated as our first quartile. Same goes with the third quartile. We will have to calculate the median on right data, and on the right part as well, there will be odd number of samples, because here we can definitely see that there are 3 samples. So that's why the same median out of the right data will be at the middle element, which is this data, and it will be considered as our third quartile. So we learned both the things, or all the things maybe, like median also, first quartile, and then third quartile. Any confusion? Now, in the case of, like if we had already the 5 number of samples, the odd number of samples in the earlier case as well. So this will be treated as our median. And in that case, if this is median, then the median out of these two data samples would be the average of these two data samples, and median out of these two data samples would be average of these two data samples. So this will be treated as our first quartile. This will be treated as our third quartile. And this will be treated as our median. Please remember, in the machine learning or data science interviews, they will provide you a list. Okay. And with that list, you need to find out the median values, first quartile, third quartile, minima, maxima, and then they will say you to plot the box plot also. So you can easily do it now. Any confusion? Perfect. So first quartile, third quartile, and median, we already found out how exactly we can do that. But still, we will learn how exactly we will be plotting the box plot out of it. We know the 5 points. We perfectly know the 5 points, maxima, minima, median, first and third quartiles. But how exactly we can plot the box plot out of it? So let's go into a stage-wise manner. First, we will arrange the complete data in an ascending order, which is already, like suppose these are the data samples, 7 to 97. Okay. First, we will arrange the data set. Please remember this step. First, we need to arrange the data set in the ascending order and plot it into a number line. Already done. Stage 1 is done. You need to arrange the data in the ascending order and then plot it and then draw it on the number line. Once that is done, you need to find the median of that data. Here, if you will count how many samples are there, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 samples are there. If there are 10 samples, then there will be two middle values, 64 and 86. Okay. If 64 and 86 both are middle values, then what will be the median? The average out of it. The 64 plus 86 would be 150, and 150 by 2 would be 75. So that's why our median is lying at 75. Okay. This 75 is our median now. Okay. You need to calculate the first quartile and third quartile. If 10 is the 10 number of elements are there in the data set, then first quartile will be like median of the data lying left to the 75, which are 7, 11, 35, 55, 64. 5 elements are there. What is the middle element? 35. This will be treated as our first quartile. And similarly, 5 elements will be on the right side of the 75, which are 86, 88, 90, 95, and 97, which is the third element, 90. So this will be treated as third quartile. So what exactly we will do? We will try to plot a box starting from first quartile till third quartile. Okay, the boundaries of the box will start from first quartile to third quartile. Okay, and we will also draw a vertical line at the median position. So like see first quartile, we are trying to plot a box, and also at the third quartile. Once this box is done, we need to draw a vertical line at the median position. So this is half plot currently. This is representing the three numbers: median, first quartile, third quartile. Now two numbers are left: minima and maxima. Okay, so we will have to use the sickle for that. Okay, sickle is nothing but we will use a kind of line to attach it with the minima position, minima dot, which is like this. And again, with the same concept, with the maximum value, we will use a line to attach the box with maxima value. So that represents the complete box plot, which is a 5-point summary, and all the 5 points are minima, first quartile, median, third quartile, and maximum. This is the way how exactly we plot the box plot by using some kind of 5-point summary. So this is the 5-point summary of the entire data set, we can easily say. So you already have understood how exactly we need to plot the box plot. So let's quickly jump towards understanding one data set, and then we will quickly see how exactly we can plot the box plot using the pandas data frame. So like suppose this is the data that we have. This is very popular data, iris flower data set, where we have 3 classes: Setosa, Veriscola, and Virginica. Okay, so if suppose we have sepal length and sepal width as our features, and petal length and petal width as our features. Sepal length, sepal width, petal length, and petal width. Based on these numbers, we will be deciding which flower it is. There are 3 kinds of flowers: Setosa, Veriscola, and Virginica. So let's quickly draw the box plot on these 4 features. 4 features we have, right? 4 features, like what is the sepal length, what is the sepal width, what is the petal length, and what is the petal width. Okay, so this is the data. So these are the libraries that are we have imported. So this is the data that we are reading, and if you will try to plot or maybe print the data frame head, you will quickly find the 5 samples. The initial 5 samples are sepal length. These are the features that we were discussing: sepal length, sepal width, petal width. And based on that, we have the classes of flower: iris setosa, iris veriscola, or iris virginica. So these are the things, and we want to plot the box plot out of all these features. Okay, so first let's extract the sepal length, these features specifically. So we can definitely extract the required features by using this technique of data frame, like spatially mentioning the columns which we want in a separate square bracket inside the data frame. Please note that there are 2 square brackets, not only one. We definitely do mistake here. Okay, so this will be the new data frame with only these 4 features. Okay, once that is done, you need to define the figure and Seaborn library. We will plot the box plot df box in this format. So you can easily see these are the numbers: maximum, third quartile, median, first quartile, and minimum. And the same thing will be represented for this feature, which is this is sepal length, sepal width, petal length, and petal width. Any confusion? So once you already have learned all these things, let's quickly discuss few of the interview questions that are being asked. I have discussed this particular theory with many of the professionals, and they asked, or they said that in their data science interviews, this question was definitely asked. So one thing was, they have been provided, like, data will be given to them and asked to calculate the median and quartiles to draw a box plot. So what 5 numbers you want to extract from the given data? What is minimum? What is maximum? What is first quartile? What is third quartile? And what is median? These are the 5 numbers that you want to extract. You know the method how to calculate the first, third, and median using the quartile technique, and based on that, you will try to plot the box plot. How do we compare the medians of different features in the data simultaneously? So in this question, you have to answer that you can use box plot because it is directly representing the median inside the box that is being represented through the box plot, and we can compare the medians of different features that are present in our data set. Okay, so this is also done. What is box plot and why do we use it? So box plot is nothing but a 5-point summary of the entire data set. Those 5 points are constituted with minimum, maximum, first quartile, third quartile, and median. That's it for this particular question. So this is it for this particular video. I hope you have enjoyed it. Thanks.